Okay, so here's another example. Okay, we have, oh, darn it, did that in the other class too. We have y equals x squared plus 5x plus 4, as you can see. Okay, now the x-intercept, excuse me, for the x-intercept, right, we have to we set y to be 0. Again, we set the other variable to be 0. So for x-intercept, y has to be 0. So that's what we're doing here. Now for this one, I could have factored it if I wanted to. It's actually not hard to factor, but I just did the quadratic formula. I mean, usually on a quiz or test, I'll tell you which method to use. If I don't tell you, you could use any method you want. Any of the two, I mean. So from the quadratic formula, right, here we have a is 1, leading coefficient. B is 5. C is 4. Plug it into the quadratic formula, we get this. Then we work with this thing. So it looks like we get -5, right? That's our negative b, plus or minus square root of 5 squared, minus 4 times a times c over 2a. So minus 4 times 1 times 4 over 2 times 1, which is this. The square root of 9 is 3. So we have -5 plus or minus 3 over 2, as you can see. So we get two solutions here. We have -5 plus 3 over 2, which gives us the first solution. The other one is -5 minus 3 over 2, as you can see. So we get this. So we have our two solutions here. These are the two x-intercepts. You can see from the graph that the graph crosses the x-axis at -4 and -1. So we get that. For the y-intercept, we set x to be 0, we get 4. So hopefully that one isn't too bad either. All right, cool. So that's just an example. I did graph it here, but really I didn't need the graph. As you can see, we were able to get the intercepts without it. I really used the graph more as like a check, if that makes sense. All right. Also, it is possible that you could have certain graphs that don't intersect the x or the y-intercept, or the y-axis, excuse me. So you can have a graph like this, y equals 1 over x. This never touches the x-axis, and it never touches the y-axis. You could see from the graph, but even algebraically, you should be able to see it. I mean, for one thing, for the x-intercept, for that, what would you do? For the x-intercept, you would set y to be 0. So you would have this. 1 over x. But if you do 1 over any number, there's no way that can be 0. It's impossible. So because of that, this has no solutions. So there's no x-intercept. For the y-intercept, well, hopefully you can see that you can't replace x by 0. That's impossible, right? You cannot replace x by 0. So because of that, it never touches the y-axis. So this is a graph that has no intercepts. It does not have an x-intercept or a y-intercept. It's not the only graph where that happens, but for now, it's a graph. For us, it's an example. Okay. And this is just another graphing example I thought it'd be good to do. So we have y equals x squared minus 4, okay? Again, just like before, we have different x values here, as you can see. And for each x, we substitute, calculate the corresponding y, right? And we get a point. That point is a solution to the equation, so it's on its graph. If you take x to be -2, for instance, calculate y. Y happens to be 0, so we get this point is on the graph. When x is -1, right? Y, okay? When x is -1, you calculate y, you get -3. So this is on the graph, and so on. Notice that we get the y-intercepts, right, at -2 and 2. That's where the graph touches the x-axis. See? X-axis. -2 and 2. Because those, when you replace x by 2 or -2, you get a 0. When x is 0 for the y-intercept, you get -4. So it's a parabola. I mean, you knew it was a parabola because we have x squared. We have a quadratic on the right side. So we get a parabola. Good. All right. So let's do another example. So here's another example. I put this kind of example on the exam before. Here, we have the x and y intercepts. We want to find them of the graph of this, but we're not going to sketch the graph though. But what's nice is we don't have to. So we want the x and y intercepts of the graph of this here. So again, for each one, you set the other variable to be 0. For the x-intercept, right? For the x-intercept, you set y to be 0 and solve for x. Doing so, you set y to be 0. This is gone, right? 7 times 0. You get 4x equals 3. 4x equals 3. Because 7 times 0 is gone. Anything times 0 is 0. So solving for x, we get x is 3/4. So that's the only x-intercept, 3/4. For the y-intercept, there, what you do is you set x to be 0. That's what I'm doing. So 4 times 0 is gone. So 7 times y we get is 3, as you can see. And we solve that for y. And we get y is 3/7. Okay? Okay. So that's what we get. Right? Again, we're setting the other variable to be 0. For the x-intercept, we set y to be 0. For the y-intercept, we set x to be 0. I put this kind of example on exams. Students sometimes have trouble with it. I'm not sure. I mean, I hope no one else does, but anyway, no one has trouble with it, I mean. But anyway, we had that example. All right. So that was some stuff about intercepts. So what I want to do now is I want to do circles. So if we were to graph a circle in the Cartesian plane, right? There would be 2 things we need at least. We need a point and the radius. The point we would need would actually happen to be the center of the circle. Namely, as it says here, a circle centered at HK with radius R, which is positive. So centered at HK, radius R, which is positive, right? By definition, it's all points in the Cartesian plane. Let me sketch a picture actually. It's all points in the Cartesian plane that are r units that are the same distance, namely r, from the center. I know this is not a great circle. There's a better picture on the next slide, but it's all points that are r units away from the center. The center in this case is HK. All right, cool. Okay, that's what we get here. And it turns out the graph of this, such a circle is the graph of this equation. That's what turns out to happen. Namely, a circle centered at HK, radius r, is the graph of this thing. Good. Okay, so that's what we get here. Right, so again, for a circle, we need two things, the center and the radius. Then we can sketch its graph, and then we can get an equation of it. Here's an example. Well, actually, no, not an example. It's a better picture, actually. Sorry. But again, this is what I'm saying here. The center is HK. The radius is R. Okay? And all points that are R units from the center. That's the circle. Notice also x minus h, right? H is the x coordinate of the center. We also have y minus k. K is the y coordinate of the center. So even by looking at the equation, you can get the center of the circle. And you can also get the radius of the circle. You know, that's equal to r squared, so you take a square root. Let me pause this. Gotta pause.